This lecture will investigate what happens when two or more tectonic plates meet up and the interesting geology that occurs at those plate boundaries. The three main ways plates can interact depends on how they are moving relative to one another: convergent, divergent, or transform. First, we'll examine divergent plate boundaries. These occur when two plates are moving apart from one another. We saw this situation in the last video lecture at the mid-ocean ridges where seafloor spreading is taking place. Each side of the ridge is a separate plate, and since the new oceanic crust is spreading away from the ridge in both directions, it is a divergent plate boundary. At divergent plate boundaries on the seafloor near mid-ocean ridges lies a unique geological phenomenon discovered in 1977: hydrothermal vents. Although the fluid looks like black smoke, and hence the name black smokers for this type of vent, it is actually superheated ocean water that gets darkened by the huge amount of minerals it has dissolved. When rising molten rock from the mantle breaks through the crust above at mid-ocean ridges, some ocean water seeps downwards into those cracks. It comes into close contact with the molten rock rising upwards through the same cracks, gets heated to upwards of 200 degrees Celsius, and dissolves sulfur and iron compounds. Heating the water lowers its density, so it rises upwards through cracks and shoots out of the seafloor as a hydrothermal vent. When scientists first discovered hydrothermal vents, they also discovered an entirely new ecosystem surrounding them that did not require any sunlight. Bacteria in the water use the minerals dissolved in the hydrothermal vent fluid to make food for themselves in a process called chemosynthesis. This allows the rest of the ecosystem to exist in the same way that photosynthesis allows all other ecosystems on Earth to exist. A second way plates can interact is by moving towards one another, or colliding, at a convergent plate boundary. Several different things can happen depending on what types of plates are converging. First, let's consider an oceanic plate converging with a continental plate. In the last video lecture, we learned this produces a subduction zone, where the denser oceanic plate sinks, or subducts, beneath the lighter continental plate, dives down into the mantle, and is melted to recycle the oceanic crust into molten mantle. As the oceanic plate subducts, friction between it and the continental plate melts some of the rocks along their interface, the same way rubbing your hands together warms them up. Melting the rocks lowers their density, so they rise upwards through cracks in the continental plate above and erupt on the surface as a back arc volcano, also known as stratovolcanoes. The Cascade Mountain Range in Oregon and Washington State are active back arc volcanoes produced by the subduction zone just offshore. Back arc volcanoes, also called stratovolcanoes, found at subduction zones tend to erupt with violent explosions of rock fragments, ash, dust, and gas. Fortunately, this type of volcano does not erupt all that often, but their eventual explosion can cause massive property damage and loss of life. The eruptions are so violent they can blow the entire top off a mountain, leaving a massive crater in its place, as is the case with Crater Lake in Oregon, pictured on the bottom left. During my sabbatical project a couple years ago, I got the chance to hike into the top of an active volcano field in New Zealand called the Tongariro Crossing. The picture above shows the most recent cinder cone the area has produced. This is where the next eruption will take place. Back in 1980, the most recent eruption of a back arc volcano in the continental United States took place when Mount St. Helens in Washington state literally blew its top off. The explosion was so violent it left only a crater and a newly forming lava dome where the top of the mountain once was. I have included in this lesson a videocast of the Mount St. Helens eruption to give you a better idea of what a back arc volcanic eruption is like. A convergent plate boundary can also occur when two oceanic plates collide. The situation is similar to what happens at a subduction zone. The older, and therefore denser, of the two oceanic plates will sink or subduct beneath the other. This sends the subducting plate into the mantle to be melted. Friction between the plates melts rock and sediments, which erupt as back arc volcanoes. These areas also produce the deepest parts of the ocean, such as the Tonga and Mariana Trenches. One more possible type of convergent plate boundary exists, between two colliding continental plates. Because both continental plates are light, neither wants to sink all the way down into the mantle. So the two colliding plates crumple together where they collide, and the crust becomes extra thick. It both sticks up higher to form mountains and sticks down lower into the molten rocks of the mantle. The geologically recent collision between Asia and India has thrust upwards the Himalayan mountain range. The last major type of plate boundary occurs when two plates move laterally or slide past one another side by side. Called a transform plate boundary, this type of interaction produces earthquakes. And other plate boundaries produce earthquakes as well. Earthquakes can occur anywhere there is a fault line, where the rocks on one side of the line are moving relative to the rocks on the other side. Transform plate boundaries are a very special type of fault line because the rocks on either side are on different massive plates. Earthquakes occur because right at the fault line, where the rocks moving one direction are touching rocks moving a different direction, the rocks are locked together by friction. They cannot slide smoothly past one another, even though the rocks a little further away from the actual fault continue to move past each other. This causes a tremendous amount of energy to build up at the fault line, until finally the rocks shatter and break, allowing the two sides to suddenly slip past each other in an earthquake. The entire process repeats itself as the fault line continues to produce more earthquakes. The San Andreas Fault Line in California is a transform plate boundary between the Pacific Plate and the North American Plate. Everything to the west of it sits on the oceanic Pacific Plate, including all of coastal Southern California. This fault line is especially dangerous near Los Angeles because of the Big Bend, or compression zone, where the fault line curves north of the city. Here, the two plates are actually moving towards one another, converging, pressing into each other a little bit. This increases the amount of friction between the rocks on either side of the fault, causing them to be locked together extra tight. That allows additional energy to build up at the fault line, which produces an extra large earthquake when the rocks finally break.